Welcome to this explainer. Okay, I want you to just take a second and imagine the ultimate peace and quiet. After a long, chaotic day of blaring traffic, people talking over each other, your phone buzzing nonstop, absolute silence sounds like an absolute paradise, doesn't it? But what if I told you that true, absolute silence is actually a biological impossibility for a healthy human brain? Like literally impossible. In fact, it's something your central nervous system is evolutionarily hardwired to hate. So today, we're going to dive into the really profound neurological, psychological, and even physical cascade of events that kicks off when the human brain is totally deprived of sound.
Let's start by looking at the quietest places on Earth, specialized anechoic chambers. These are these incredibly engineered rooms built to absorb literally all acoustic reflections, which drops the background noise way, way below the threshold of human hearing. Now, you'd think this would be the ultimate meditation retreat, right? Nope. No one has ever been able to last inside one for more than 45 minutes. And why is that? Well, because when you strip away all that ambient environmental noise, the stuff that constantly masks the physiological hum of our own bodies, the brain actively rebels. The reason for this rebellion comes down to this really fascinating mechanism called homeostatic plasticity. See, when external sound just vanishes, the sensory signals your brain expects drop right off a cliff. So to compensate for this sudden acoustic void, your brain essentially grabs its internal volume dial and just cranks it all the way up. It scales up what we call neural gain. It starts amplifying the faint biological noises of your own body. We're talking about hearing your own heartbeat, the blood rushing through your veins. Eventually, it even starts creating phantom sounds. This right here is the physiological root of distressing tinnitus. Your brain is just so desperate to keep its connection to reality that it will literally synthesize its own acoustic scene.
So that brings us to our first main area, the psychological descent.
It is absolutely wild how predictably our psychology just completely unravels in the void. Look at this timeline. From 15 to 60 minutes, you actually hit a sort of therapeutic window. Your blood pressure drops, muscle tension eases up, and you relax. But cross into that 1 to 4 hour mark, and perceptual shifts start kicking in. You totally lose your anchor to time. Minutes can start to feel like hours. Push it between 4 and 8 hours, and the brain's default mode network goes into absolute overdrive. It initiates what's called the Ganzfeld effect, where intense, unconstrained, multisensory hallucinations start to take over. By 8 to 24 hours, you're looking at severe executive decline and a massive loss of working memory. And if you push past 24 hours, people often enter these severe psychotic-like states marked by intense spatial disorientation and paranoia that closely mimic trauma responses.
And you know what's crazy? This exact psychological unraveling mirrors this ancient thought experiment called the floating man, proposed by the 11th century scholar Ibn Sina. He basically said that if a person were suspended in a total vacuum, completely blind and deprived of all sound, they'd still maintain an undisputed awareness of their own existence. And modern neuroscience proves him absolutely right. The human brain continuously acts as this predictive engine, right? Always building a model of the outside world. When you starve that engine of novel external events, it doesn't just power down, it turns uncomfortably inward, generating its very own reality just to fill the vacuum.
Moving on to our next section, let's talk about the silent decline.
9.1%. That is a staggering number. Research has established this incredibly powerful link between hearing loss, cognitive decline, and dementia. In fact, hearing loss accounts for up to 9.1% of the modifiable risk for dementia. To really put that into perspective for you, preserving your hearing actually ranks above preventing other major risk factors like smoking, high blood pressure, and even lack of exercise. It's that huge.
So why does this happen? Well, untreated hearing loss actively deprives the brain of vital sensory data. And here's the really alarming part. People wait an average of 8.9 years from their initial diagnosis before finally getting hearing aids. Think about that. During nearly a decade of this progressive silence, the brain is slowly changing. It's starving that predictive engine we just talked about, and this lack of stimulation leads to things like social withdrawal, depression, and cognitive fragmentation. The brain basically has to work incredibly hard just to make sense of degraded, muffled auditory signals, which ends up stealing crucial cognitive resources from other vital functions. Okay, let's shift gears to Section 3, the fourth pillar of balance.
The physical impact of silence is honestly just as staggering as the mental impact. Research shows that 20 to 70% of children with sensory neural hearing loss also experience balance issues, and that prevalence shoots up the more severe the hearing loss is. Why? Because the auditory and balance organs aren't just neighbors, they are intimately connected. They actually share the exact same fluid and chemical makeup deep within the inner ear.
Because of this, vestibular dysfunction is a highly common comorbidity when you have profound hearing loss.
To really understand why this happens, we need to quickly define the vestibular system. These are the sensory organs in your inner ear that contain otoliths, which are basically these tiny calcium crystals, along with hair cells that detect gravity and acceleration to keep you oriented. Now, classically, medical science views our equilibrium as a triad, a successful integration of your vision, your touch, or proprioception, and this vestibular input. But as we're increasingly learning, that classic triad is actually missing a critical piece.
Hearing actually acts as the crucial fourth pillar of postural control. Our brains constantly use ambient sound to create these subconscious acoustic anchors by calculating microscopic intraeural time differences, which is literally the tiny delay between a sound hitting your right ear versus your left ear, and intereural level differences. Your brain is constantly building a 3D representation of the physical space around you. These sounds act as invisible auditory landmarks that ground you and physically keep you upright.
And the reality of this is pretty shocking. If you place a person inside an anechoic chamber, totally removing all those spatial audio cues that usually bounce off the walls, their balance system degrades incredibly fast. In fact, within just 30 minutes in total silence, the lack of spatial auditory landmarks causes such severe physical sway that most people experience complete equilibrium failure. They literally have to sit down to avoid collapsing. So yeah, sound literally holds us up.
Let's move into our final section, how sight shapes sound.
When profound deafness occurs, your brain flat out refuses to let the auditory cortex just sit there in the dark doing nothing. Instead, it engages in something called cross-modal plasticity. The unused auditory regions of the brain are dynamically repurposed and actually colonized by remaining sensory modalities, most commonly vision and touch. Basically, the cortex completely restructures itself so it can process what it can see and feel instead of what it can hear.
Now, for a really long time, the clinical community was absolutely terrified of this happening. The old, outdated view assumed that if you allowed deaf individuals to rely heavily on visual communication, like lip reading or sign language, this visual takeover would irreparably harm their chances of adapting to a cochlear implant later on. But the new view, which is heavily backed by modern evidence, completely flips this script. It turns out visual cues actually provide a vital functional resource. They keep the multisensory networks highly active and effectively prime the brain for future hearing recovery.
And modern brain mapping reveals exactly how this works. When researchers used imaging to scan the brains of deaf adults, they found something incredible. Those who were good speech readers, meaning they had high visual responsiveness in their auditory cortex, well, that actually predicted significantly better speech perception 6 months after getting a cochlear implant. So rather than competing with hearing, strong visual processing indicates a brain that is flexible, highly engaged, and absolutely ready to learn.
So what you should really take away from this is that cross-modal plasticity isn't the brain just frantically growing chaotic, random new pathways. Instead, the brain is brilliantly leveraging pre-existing, dormant, multisensory connections. It simply activates networks that were always there, essentially using the scaffolding of sight to rebuild the complex architecture of sound. It's just a beautiful, incredible survival mechanism. So, to wrap this all up, we've seen that the human brain completely refuses to accept absolute silence. It will aggressively turn up its own internal volume to the point of hallucinations. It heavily relies on the ambient hum of the world just to keep us physically standing upright, and it will literally rewire our eyes to do the job of our ears. The interconnectedness of our nervous system is just staggering. So I'll leave you with this provocative thought. If your brain can weave sight into sound just to survive the void, what other hidden realities is your mind silently building for you right now?